Bismillahirrahmanirrahim. Today I want to talk about solving linear equations. The first thing that we have to appreciate is what does that mean to solve for linear equations? Well, linear equations are equations of lines, and when we solve linear equations we have to be given like two linear equations or two equations of line, and we have to find the point that is common to both of them. Well, what does that mean? Well, I have here before us two lines, and there's a blue line and there's a green line over here, and I've drawn them out. I've drawn them out here on this Cartesian plane. Now, as you can see, these two lines, the blue and the green line, they intersect right here at this red point over here. And in fact, we can write that down. That to me looks like the ordered pair 1, -2. So the ordered pair 1, -2 is the intersection of these two lines. That's where they cut each other, they cross each other. Okay? Now, the first thing is you have to understand what it means for a ordered pair, for a point to satisfy the line, the equation of the line. That is, if I take any point that's on the blue line, any ordered pair that's on the blue line, we can pick this one here, for example. Here x is 0 and y is 2. If I pick any of the millions and infinite number of points that are on this blue line over here, and I substitute those ordered pair over here in the blue equation, it will satisfy the equation, meaning it will make the equation true. But if I pick any random points from over here and I substitute that in the equation, it will not be true because that point is not on the line. So let's try out, let's try out at least this one point over here, and let's just substitute this point in the blue equation and see what happens. So that's 4 times 0, okay, plus y is 2, and the question is, does that is equal to 2? Well, 4 times 0 is 0 last time I checked, and this is indeed 2 is equal to 2, and that works out. Now this point, 0, 2, is not on the green line, right? If you were to substitute that point in the green line equation, it will not work because it's not on the green line. So let's see what happens then. So I substitute 0 for x, and I substitute 2 for y, and do I get a 3? Well, this is -2. Does -2 equal 3? Not the last time I checked, so that's not true, right? So you can see this point over here satisfies this equation. When we say a point satisfies an equation, we say that it makes the equation true if you substitute that in. And this point again does not satisfy this equation because it's not on the line. So when we say a point satisfies an equation, we mean that when you substitute that ordered pair in the equation, it makes that ordered pair it makes that equation a true statement. And if it does not, then it makes this it's a bogus statement like that. -2 equals 3. -2 does not equal 3. What kind of statement is that, right? So that's what we mean when we say a point satisfies a particular equation. Now, if you were to continue this particular exercise, and we say that, well, we can pick any other point, right? Let's say we pick a point like I don't know, let's pick this point 3 and 2 right here. Okay, this point is 3 and 2. Now this point 3, 2 is not on the blue line, and it's not on the green line. So if we substitute that point in either one of these equations, it should not work. It should not work. So let's just see what happens if we do that. So 4, so I'm going to substitute that here first. 4 times 3, and then plus y, which is 2. Now the question is, does that equal to 2? Well, 4 plus 3 is 12, so that's 12. Plus 2 is equal to 2. 14, is it equal to 2? Well, not. It's not true at all. 14 has not equal to 2 last time I checked. Now, so this, as we can see, when you substitute this point in here, it does not work, and that makes sense. How about in the other one? Well, let's try this. Let's substitute that over here. All right. So x is 3 minus y, which is 2. Does that is equal to 3? Well, 3 minus 2 is 1, and 1 does not equal to 3. So as you can see, this point over here also satisfies neither of them, and that makes sense because that point is not on the line. Okay, so the first thing that we have to appreciate is that if a point is on the line, it will satisfy the equation of the line. It will make that statement true when we substitute that point in the line. Okay, so and if it's not, it will not make that statement true. Now, if you notice this line now, if you focus on these lines, right, each line has infinite number of points, right, and both of them have infinite number of points, but there's one point that's very particularly special for them, and that's this point here, because that's the only point that's common to both of them. That's the only point that's common to both of them. In other words, this point, 1, -2, if we were to substitute this over here, and if we were to substitute it over here, they should both work, right? They should definitely both work because they're both on the line. And in fact, that's the only point in the whole Cartesian plane that will satisfy both equations, okay? So as a matter of exercise, let's just do it, okay? So 1, -2. So x is 1, and y is -2, and I substitute those that ordered pair in the first equation. 4 and -2 is what I substituted. Does that equal to 2? Well, 4 times 1 is 4, minus 2, well, that's 2, and definitely 2 does equal to 2. And if I substitute that same ordered pair over here, so let's do that over here. So x is 1, and be careful, there's a negative sign here. 1 minus -2, I'll put that maybe in like this. 1 minus -2. And does that is equal to 3? Well, minus is plus, like this, so that 3 does indeed equal to 3. So now you can see that this ordered pair, 1, -2, satisfies both equations, and that's what we mean by a point to satisfy both equations. That means it will make both of those statements true. And mind you again that this point, the point of intersection of the line, is the only point that will satisfy both equations. Now, when we say solve linear equations or solve this set of equations, we mean that if you're given these two equations, if you're given equations of lines, we are to find the ordered pair, that satisfies, both equations. So when we say solve a pair of linear equations, that means finding the ordered pair that satisfies both equations. And that's what we're going to learn today. Now, here we kind of graphed it out. In fact, that's one way of finding it out, that you can graph the lines and try to guesstimate guess what the point of intersection is. Okay? So that's a legitimate way to solve linear equations. In general, however, there are two ways that we solve a pair of linear equations, and that is using the elimination method and or using the substitution method. Okay. Now, first of all, you have to understand what that means. So, elimination method and substitution method, if you didn't want to go through the trouble of graphing, I'm trying to guess where they intersect. So, elimination method, this is kind of tricky. What do you maybe it's better off if it's named more descriptively, like, so eliminate one of the variables. So the idea here is to eliminate one variable. Okay, so now the way you do that is, the only way you eliminate the variables is by adding the two equations. Okay, so now, that's what that means in a long sentence. So elimination method means to eliminate one of the variables by adding the two equations. Okay, because you can only really solve one variable at a time. Okay, so in this case, for example, if you were simply to add these two equations, just line them up and add them, 4x plus 1x, that will give you 5x, and y minus y, that's just, they cancel each other out. It's like 0, right? So they just cancel each other out, right? So, and then you have 2 plus 3 is 5. So you have 5x is equal to 5, right? And then you can solve for x, and x is equal to 1, like this. Okay? Now, so that's what it means to eliminate. So the elimination method really means to eliminate one of the variables by adding the two equations. Right? Now, let me tell you something. You can't just plain add two equations and expect the variables to get eliminated all the time. For example, if I have 4x plus y is equal to 2, and over here I had x plus 6y is equal to 3. Now, if you add these two equations, there's no way you're going to eliminate no variable over here, because if you add them, you get 5x plus 7y is equal to 5. Now, you didn't eliminate any variable. X and y are still both there. So the idea is to get rid of the two variables, get rid of one of the variables. And the only way you get rid of one of the variables, you have to understand, is that if one has a coefficient that is opposite of the other. That is, if you have x over here in the first equation and if you have x over here in the second equation, the only way you eliminate them when you add them together is that if their coefficients are opposite. If one is 4, the other one is -4. If one is 1, the other one is -1. Or if one is -5, the other one is +5. Okay, if one is -10, the other one is +10. And when you add them together, that's when you eliminate. So you can only eliminate variables if they are if their coefficients are opposite. In this case, we got lucky, so that's 1 and -1 over here. So they when we added them, they got eliminated. But you only eliminate variables if they are opposites. Okay, if they are not opposites, then what do? You stuck? No, you can get them to be opposites. Okay, get one variable coefficient, get one coefficient. Let me just say, get one coefficient. Okay, to be opposite. To be opposite. OPPOSITES. So if they're not opposites, you can manipulate the equations to be opposites. For example, if I give you this particular equation, 4x plus 3y is equal to 2, and then you have x minus y is equal to 3. I just made these up. Well, nothing is opposites, right? Well, it would be nice if there was a -4 over here, right? Then you could add this and get rid of the x's. Or it would be nice if there was a -3 over here, and then you can add them up, right? Well, that you see, that's what you do. You start like thinking, okay, well, it wouldn't be nice if there was like a -4 over there, right? Or it wouldn't be nice if there was like a -3 over here. So you have to think like that. And once you think, oh, it'd be nice if I have -4. Okay, well, I don't have it, but I can make it, but because you can multiply this whole equation by -4, see, and then you get the x to be -4 in the front. So I can do that. So if I multiply this whole equation by -4, then I get this. I'm going to rewrite both of them. I get 4x plus 3y is equal to 2. And then on the second one, I get -4x, -4, that's +4y is equal to -4 times 3. Don't forget this 3 over here on the way on the other side. So that's -12. Now, see, if I add these two, these will cancel, right? Now there we go. So for 7y is equal to -10, like that. So if they're not opposites, you have to get them opposites. Okay, so that's the idea. So the concept of elimination is to get rid of one of the variables. So you eliminate one of the variables so you can solve for the other. So here's the first method of solving linear equations is the elimination method. What does that mean? You eliminate one of the variables, for God's sake, so that by adding the two equations, so you get rid of that one variable so you can solve for the other way. So you eliminate one variable by adding the two equations, and the only way you get them to be eliminated if they have opposite coefficients. And if the coefficients are not opposites, you get them opposite, and you think which one's the best one to get opposites, and you get them to be opposite by multiplying that equation by that number. Okay, so let's solve this particular set of linear equations using the elimination method. So now we know what to do. In this case, we kind of got lucky. As I said, these are opposites already, so I'm just going to add them. So I get 5x, and the y's are eliminated. Ta-da! And then to add, that's 5, and divide both sides by 5. I get x equal to 1. Once I have solved for one of the variables over here, like this, once I've solved for one of them, I can substitute this either in this equation or in this equation over here, and I can get solve for y. So I substitute this in the, I'm going to use it in the bottom equation because that looks easier to me, because you know, why make life harder than it has to be, right? So I'm going to rewrite that. So I put 1 over here, 1 minus y is equal to 3, and I solve for y. So I subtract 1 from both sides. Look how methodical I am. So minus y is equal to 2, and this, I don't want to know what minus y is, so I divide both sides by -1. I want to know what y is, so that's -2. So y is -2, and there we go, and there we have it. So we have solved this equation using the elimination method. So now we have x is 1, y is 2. So the ordered pair 1 and -2 is the ordered pair that satisfies both of these equations. Okay, we got that? Okay. Now, the second method of solving a set of linear equations is by substitution method. Now, substitution method says that what you do is you solve one of these equations for either x or y. So if you're given the equations in x equals or y equals something, that's great. But if they're not, you solve them, you get them to be x equals to something or y equals to something, and then you substitute that in the other equation to solve. Okay, so here we're going to try to solve this same set of linear equations using the substitution method. So here we go. So I take either one of them, and I think I'm going to use this one. So I take this one over here because I like to work with simpler looking equations, you know what I'm saying? So I take that one, x minus y is equal to 3, and I solved it either for x or y, okay? So here I'm going to solve for x. So I'm going to add y to both sides like this, okay? And then I'm going to get, that goes away, so x is equal to 3 plus y. There we go. So I solve this. Now, and then what I do is I take this, all right, and I put this in place of x in the other equation, like this. Okay, so I know what x is, so I substitute that in place of x. Now look, I took this equation and I solved it for x, right? And then I took whatever I got and this is what I got, and I substitute that in place of x over here. Now, sometimes what students do is something silly. What they do is this. They take this equation and they solve for x, and then they substitute that back in the same equation. There's no point. They're going in circles, all right? You're not using the other equation at all, right? So that won't work. That you'll see they'll end up going nowhere. So so if you do that, then what you end up getting is like 3 equals 3. Oh, that's good to know, but that doesn't solve the equation. So you solve one for x or y, and then you put that whatever you get in the other one, the equation that you haven't used yet. Okay, so don't make that silly mistake. So now we're going to substitute this in place of x over here. So, all right, so I'm going to bring this equation down 4, and I'm going to put that 4 times x, right? Now we know x is this 3 plus y, and I'm going to substitute that in there. And then plus y is equal to 2. Now you see there's only y's in here. That's cool. Now I can solve for y. So distribute this. That's 12 plus 4y plus y is equal to 2. That's 12, and combined like terms, that's 5y is equal to 2. And I subtract 12 from both sides like this. Alright. Then that's gone. That's 5y is equal to minus 10. And I divide both sides by 5 to get y is equal to -2. Ta-da! I got the same answer, and I better get the same answer, right? So here's y is equal to -2. And then I can use this to substitute either here or here to get the x. I'm going to substitute here because this one is already solved for x, right? So I'm going to, right, you follow what I'm saying? You know what y is now. You just have to go back and find out x. So you can substitute here. That's cool because it's already solved for x. Because if you go substitute over here, then you have to solve for x, okay? Either way, you can substitute it going back into the other equation, okay? So if you put, let me rewrite this over here. X is equal to 3 plus y, and we just found out y was -2, 3 minus 2, and x is 1. So there we go. We found our x value. So that's how you solve using the substitution method. So x is 1 here, y is -2. As you can see, we used elimination method and substitution method. So in the substitution method, what you do is you solve one of the equations that's given. Solve one of the equations either y is equal to like this or x is equal to like this, and you use whatever you solved it to and substitute in the other equation to solve for one of the variables. Okay, and once you solve for x or y, then you can substitute whatever you find into the other equation to find the other ordered pair. Okay, so this is how you solve a set of linear equations. Before I finish, just let's look at these two examples. So here again, our instructions are to solve these linear equations. So, and these two are given, it looks like, in the slope-intercept form, y equals mx plus b, and these two are given in the standard form. Okay, so, and then as I said, you can use any form that's convenient. You can use elimination form or you can use substitution form. In this case, see, these are both solved for y, so it's very easy to just substitute one of these into the other. So you can just substitute this, you can use a substitution method in place of y, because y equals that. So you can say x minus 3 is equal to 4x minus 9. So I've taken this and substituted in place for y, and I got x minus 3 is equal to 4x minus 9. Now all I have to do now is just solve for x, don't I? So I subtract x from both sides like this, ta-da, and I get minus 3 is equal to 3x minus 9. I add 9 to both sides, I get 3x is equal to, add 9 here, that goes away, add 9 here, you get 6, and divide both sides by 3, I get x is equal to 2. So here's my x. Now, and then I just have to solve for y. I can substitute this in place over here or over here and solve for y. Well, I'm going to use the bottom one because that looks easier. So y is equal to x is 2 and minus 3. So y is equal to -1. There it is. So the ordered pair that satisfies both of these two equations, x is 2, y is -1. That's the solution for this particular problem. Alright, how about this one over here? Now, these are both given in standard form. If you add both of these, you don't eliminate them, because as you can see, you don't eliminate anything because neither of the coefficients are opposite. But you can make them opposites, right? Because you can multiply this one whole thing by -1, or you can multiply the other one by negative and make the y to be positive, right? So if I multiply this whole equation by -1, this thing becomes minus x plus y is equal to -3. You have to multiply every single term, okay? And then the bottom equation can remain the same. 7x minus y is equal to -3, like this. Now I can add them together, okay? So this will give me 6x. These are eliminated, and I have -6 over here. Add them together. X is equal to -1. Then I can substitute this in either one of these equations. I'm going to put it in the first one because, again, it looks simple. I like to work with simpler equations, so I substitute that over there. So -1 minus y is equal to 3, right? So, and then I add 1 to both sides. Let me just do that here. I add 1 to both sides over here like this. That's gone, so minus y is equal to 4, and y is equal to -4, like this, by multiplying both sides by -1. Okay, so ta-da. So I have this. So the ordered pair that satisfies both of these equations is -1 and -4. Now, ideally, you would go back and check these. You would substitute that ordered pair in both of these equations, make sure it makes sense, and that I didn't make a silly mistake, and I may have actually. You can do that and maybe catch my mistake. So, or ideally, you should go back and substitute these solutions into the original equations to see if they work. Okay, so sometimes it's easier to use the substitution method, sometimes it's easier to use the elimination method. You just have to work with them to find which one is the easiest way. Inshallah, we shall elaborate on this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.